Okay, turn to page 192. 192 is a complete blank page, and we will have sometimes where I will add an example, and your textbook has blank pages built into it. So we have a blank page on 192, and the question or the example that we're going to do is we're going to graph y equals -1/2 x cubed. Now the reason I added this example is because most of the examples that we've done in our textbook, they've given you a graph to start. But you are also going to be required to graph a bunch of things based on those 4 colored papers that we did at the beginning of the year. So what you need to be able to do is you look at the equation and say, hey, that's related to one of my original graphs that I know. In this case, is it the square root, the absolute value, the x cubed, or the 1/x graph? Oh, it's the x cubed graph. And you can see that because you have an x and it's getting cubed. So you have to sort of be able to look at the equation and say, what was the original graph before extra numbers were added? And in this case, the original graph was x cubed. So off to the side, you draw a quick sketch of your original graph and say, I know what that shape looks like, and I probably know some key points on this graph from before. Then you can look at the equation and say, well, what has changed? What's new? We've got a 3 out in front. What does that 3 do? Affect your x's or your y's? Y's. And we're going to multiply y by multiplying y by 3. So we would call that, we'll just use initials, vertical stretch. The -1/2, that will multiply your x by what? -2. So it's inside the brackets. It's going to do the reciprocal. We have a negative, so we have a horizontal reflection and a horizontal stretch. You might have to rewatch the video later. If you look at all these letters, you're like, I don't remember what they stood for. So to graph this function, we say, well, what are some key points that I'd like to look at from my original graph? And 0, 0 is where this graph sort of turns, so I'll look at 0, 0. Maybe I'll choose those 3 points. You could also choose 2, 8 and -2, 8. Of course, the more points you do, the better or the more accurate your graph is going to turn out. Draw your arrows, and then above your arrows, write what you're going to need to do. We're going to need to multiply our y values by 3 and our x values by -2. What's going to happen to our points? So 0, 0, that's some nice mental math to be able to do. 1, 1, if x by -2 and y gets multiplied by 3, and x multiplied by -2 and y multiplied by 3. And usually I suggest drawing your new graph on a new set of axes. So we're going to have, for our green graph, we're going to have 0, 0, -2, 3, and 2, -3. And once again, I did something sneaky that if I did this on the final exam, they would take off a half a mark. What do you think it is, Ramsey? I didn't label anything. So even though you're like, isn't it obvious? And I would say, yes, it is. But isn't it obvious that these were my points and that's what I labeled, that each of my marks go by 1? Yes, but you still need to label them. So you have a couple of options for labeling. What I would recommend for labeling is labeling your points. So if you label this point as -2, 3, now it becomes obvious that my marks are going by 1s this way and by 1s this way. In fact, labeling that 1 point would be, on the exam, sufficient not to lose that half a mark. But for clarity, I would recommend you label all of your key points that you've done. If those are the points that you meant to do, label them. Because sometimes when we label a point, we realize, oh, I actually drew it in the wrong spot by accident. And so it becomes a way of checking as you're doing your work. So our graphs need to be labeled. I remembered my arrowheads on the end of the graph, and this is the graph of, move it up. Oh, I'll just rewrite it here. This is the graph of that equation. So we've actually learned quite a bit of powerful stuff. Because if you think about, if I showed you this 3 days ago and I said graph this, you'd be like, oh, whoa. You might have been able to do a table of values, because that's what you can do to always find a graph, but you would have felt probably not very confident in graphing it. Hopefully by the end of this unit, you can feel confident in graphing just about anything. And say, if I know what the graph looked like to begin with, I know what any graph that you change it to will look like, and I can create that.